Good evening students. This is your first physics class of class 9th and your first chapter of physics is the chapter motion. As you had already taught this chapter in your lower classes, in this class we are going to discuss about these topics. In class 9th you are having the difference between rest and motion, distance and displacement. Then we will discuss about the different parameters related to motion. Those are speed, velocity and acceleration. Then graphs which will represent the nature of the motion, and then the equation which will represent the motion. So let us first discuss about rest and motion. As we know that rest state of a body is defined if the body's position does not change with respect to time, then we will say that the body is at rest. And if the position of the body changes with respect to time, then we will say that this is in motion. So in order to describe the motion of a body, first we have to locate the position of the body. In order to locate the position of a body, we should have an idea of frame of reference. So a body is at rest or motion, it depends upon the observer. So the observer has to take a reference point, and from that point he has to study about the motion of the body. Suppose take an example of an ant. Suppose there is an ant and his position is at this point. So in order to define the position of this ant, we have to go for the frame of reference. Frame of reference means we have to choose a origin, or that is called as reference point, or that is called as our 0 point, or we can say that that is our starting point. So for a different frame of reference, the position will be different. First let us take a reference point, suppose here, and let it name it as point O. So if I want to define the position of this ant, how will I define? I will say that from point O, which is my reference point, the ant is situated, suppose 10 centimeter towards this direction. So in this way I will define the position of this ant. Suppose another person will not take this point as its reference point. Suppose for him the reference point is this one is its reference point. So if that becomes its reference point, then the position of ant will be different. So how we will define the position of this ant? For that we have to go for the coordinate axis. That is, suppose along this direction, along this east direction, we are having our x-axis, and along, suppose towards north, we are having our y-axis. So how will I now locate the position of this ant? So how will I say that suppose from point O, which is our reference point, let us go from reference points towards east. Suppose this is your 15 centimeter. And so first we will go towards east. How much distance? 15 centimeter. And then towards north we will go, suppose this corresponds to 10 centimeter. So this will be the position of this ant. So how will I locate the position of this ant? I will say that the position of this ant is 15 centimeter and 10 centimeter. So this is an example of frame of reference, that if we will take different reference point, so the different position we will have. So this motion can be divided into three types, that one is your 1D motion, 2D motion and 3D motion. 1D motion means, suppose the ant is going only along this line, then we will say that this is the 1D motion. Suppose the ant is moving along this plane. Suppose the ant is moving along this plane, then we will say that this is the motion of the ant is 2D motion. Suppose the ant is having wings, so he can fly over the atmosphere. If that case arises, then we will say that that is your 3D motion. So in our class 9 we are going for only 1D motion. 1D motion means motion along a straight line. So we will go for motion of the body along a straight line. So motion along a straight line. So first we will discuss about distance. Distance, as you know, distance is the actual path travelled by a body. So how will I define distance? The actual path travelled by a body. So since a body will move in a straight line, so we will now represent the motion of a body in a straight line, and we have to define our coordinate system. Suppose this is the origin, this is our positive x-axis, and towards left of O we are having negative x-axis. So first let us go for distance. Suppose the body is, the starting point is here and he is moving from O to suppose A. So what is the distance? Distance will be your is equals to OA. Suppose this OA is equals to 5 centimeter. So what is the distance travelled? OA is equals to 5 centimeter. Then we will go for displacement. What is your displacement? Displacement is the shortest distance between the initial position and the final position. So your displacement, how will I define? Displacement, the shortest distance between initial and final position. So suppose this is OA is its distance. So for a linear motion, now this displacement, if you want to calculate the displacement, this is the final position and this is the initial position. So in order to calculate the displacement, you can write that final position minus initial position. So here we will have the final is 5 minus 0, you will have is equals to 5 centimeter. Let us go for another example of displacement. Suppose now the body is moving along this direction. It first moves from O to A, then it goes to point B, which is at a distance of 10 centimeter along x-axis. Again it is coming back to point C. So what is its initial position, and the position you are suppose is 7. So suppose then our final position becomes point C, which is having coordinate 7 centimeter. Initial one is, as we have taken it, point O, and its coordinate is 0. So your displacement will be now again 7 minus 0, 7 centimeter. Suppose the initial point is A and the final point is C. Then what will be your displacement? No, 7 minus 5, that will be your 2 centimeter. Let us now differentiate between this distance and displacements. In order to define distance, we need not to describe the direction. Whereas in order to define the displacement, we have to describe the direction. So whenever a physical quantity requires only numerical value, that is termed as scalar quantity, and if we require numerical value as well as its direction, then that is termed as vector quantity. So the first point regarding distance and displacement is that first point you can write the definition. So first, distance and displacement, you can first define its definition. This is the actual path traveled by him, and this is the shortest distance between initial and final point. The second point is that in order to define the distance, we require only numerical value. So distance is termed as a scalar quantity and displacement is a vector quantity. Vector quantity means you require the numerical value, which is termed as magnitude, plus with a direction, and this is you require only magnitude. The third difference is distance cannot be 0 or negative, whereas displacement, it can be 0, positive, and as well as negative. So let us discuss about this vector quantity and how displacement can be 0, positive and negative. So vector quantity means, suppose this is my coordinate system and this is our plus x axis. That means if a body is moving along this direction, we will say that the body body will have positive direction. If the body moves along left, then we will say that this is your displacement can have negative value. Suppose take an example. First I will define a positive value which I had already defined. Suppose the body is starting at point A, and if it is going from point A to point B, so what will be the displacement? Displacement will be I can write del x, which means that x2 minus x1. x2 means the final position, x1 means the initial position. So the point B is its x2 and the point A is x1. So the B minus A will give you, suppose this is O, so your displacement will be OB minus OA. And since the body is moving along this direction and its final direction is along this direction, so it will have positive value. Suppose the body starts from point A and it is going to point B and returning back to point A, then we will say that the displacement will be 0. This is the first case, positive case. Second case is that if the initial position becomes the final position. So the displacement del x will be equals to 0 if your initial position is equals to final position. And the third case is your negative direction. So when the displacement will be negative. Suppose the body is initially at point B. The body is initially at point B and it is moving along this direction, point A. Then what will be its? So suppose the body is its initial position x1 will be OB, and suppose final position is x2. Suppose the final position is point C, then we will have OC. Then in this case, what will our displacement? Del x displacement will be OC minus OB. So OC minus OB, which will give you a negative displacement, because the direction will be towards this, that is towards negative x axis. So let us wind up this class by doing a question. So suppose the question is, which of the following pairs represent negative displacement? minus 3 meter and final is minus 7 meter. Third option is given. Suppose 7 meter, here it is minus 5 meter. So how will we do? We will calculate displacement by using the formula del x is equals to x2 minus x1. So this will represent x2, this will represent your x1. So in your this we will have a negative sign, then we will say the negative displacement. So here if you will calculate del x, so it is coming 5 minus 3, which will be 2 meter. That means it is showing a positive displacement. Then for second case, del x is equals to, what will be the answer? Minus 7 final position minus of minus 3. So this will give you minus 4 meter. So since a negative sign comes, so this is representing a negative displacement. Here suppose minus 5 meter minus 7. Minus 5 minus 7, that is a minus 12 meter. That means this, in this case your negative sign is coming. So this is also the case of negative displacement. So this is all about your distance and displacement. In the next class we will be discussing about your velocity